Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azrim bin Ahmad, and today I would like to talk about Chapter 3, Partial Derivative. Before I proceed with my explanation, I would like to introduce topics that will be discussed in Chapter 3. There are 5 topics altogether, and it will start with functions of two or more variables, partial derivative, the chain rule, implicit partial differentiation, and last but not least, extrema of functions of two variables. By the end of this chapter, you should be able to evaluate yourself whether you know how to evaluate multivariable functions, identify the domain and range of multivariable function, find the partial derivative, solve differentials by using chain rules for explicit and implicit differentiation, and locate critical points and determine its classification using second partial derivative test. When you deal with function of a variable, I believe you are familiar with this mathematical expression, such as you have y is equal to fx. So this is the mathematical expression to explain about function of a variables. So you will call variable x as independent variable. Meanwhile, variable y, you call it as dependent variable. For function of two or more variables, normally we will use this mathematical expression, such as z is equal to some function x and y. I believe when we start with topic 1.3 for chapter 1, you have been introduced with this notation, and this notation or this expression will always produce surface in three-dimensional coordinate system. So this is what we will be talking about in this chapter 3. If you have your module with you, turn to page 166 onwards. Now, we would like to focus on topic 3.1, which is function of two or more variables. Before I proceed with the explanation, so when you have this expression for function of two variable, you will always call x and y as, again, independent variables. Meanwhile, you will call z as dependent variable. The reason being, the value of z will always depend on the variables x and y. So by the end of topic 3.1, you should be able to evaluate multivariable function, identify the domain and range of multivariable functions, and last but not least, sketch the graph of two variable functions. As you can see on the next page, these are types of basic examples to explain about how to evaluate multivariable functions. So for question A, that is a function depending on two variables such as x and y. So I think you can go through this example on your own. Meanwhile, for example 3.1.2, this is a type of situation or real world problems that can apply concept of functions of two or more variables. So let us pay more attention towards the description given in this box, such as for functions of two independent variables, z is equal to function f x y, the domain is the set of all possible values x and y. The range of f is the set of all possible values of z from the domain. So basically, the domain is defined as the set of all possible values x and y, and these possible values x and y will lies in two-dimensional coordinate system that involve variable y and variable x. So let's take a look at the first example 3.1.3. Okay. For the first example, such as z is equal to some function cosine y and sine x. So if you look at the right hand side, this actually the multiplication between two trigonometric function cos y and sine x respectively. So before that, try to recall back what you have learned in topic 2.1 in chapter 2. Basically, we discussed the domain of all possible functions, and we did discuss about trigonometric function, because if we are able to recall it correctly, basically if you have any exponential, trigonometric and polynomial function, the domain should be always from negative infinity until infinity. So basically, if you look slightly on the functions on the right hand side, there will be no problem appear for these two functions, because both functions are trigonometric functions. By default, if you choose any value for x, any value for y, if you use your calculator, you will get the value. There should be no problems with whatever you have on the right hand side, the function on the right hand side. So basically, there is quite different when you try to written down the domain of function of two variables. If you try to compare it with domain of vector function, so we will use z is equal to some function xy, hence we will have domain of function f, and in this case it has been explained as set of all possible values x and y. I will have xy such that x and y belongs to any real number. So it will indicate to us that you can choose any value for x, any value for y, because x and y belongs to any real numbers. So what should I do next? I will try to answer question B. Okay, for question B, you have been given with z is equal to ln 3 minus x minus y. So on the right hand side, you will see you have this logarithmic function. And recall back, when you have logarithmic function, the argument of the logarithmic function should always larger than is 0. When you try to include 0 and below than 0, when you use your calculator, you will see that you will end up with math error or undefined. So hence explain why the argument of the logarithmic function, which is 3 minus x minus y, should always larger than 0. So you use the inequality properties so that you are able to write it into form you are familiar with. So in this case, I'll have 3 larger than x plus y. If I try to rewrite it into a normal form, I'll get x plus y less than 3. So basically, the domain of this function f is equal to set of all possible values x, y, such that x plus y less than 3. So when you have this answer as the domain of this function of two variables, so basically the author or your lecturer might test you whether you understood or not, such as they can come up with this question: sketch the domain. So when you see this kind of question, so you have to sketch it in two-dimensional coordinate system, because x, y obviously is in two-dimensional coordinate system. So you have to sketch variable y and variable x. Meanwhile, you have x plus y equal to 3. For example, try to sketch x plus y equal to 3 will give you what type of curve in 2D. Basically, x plus y equal to 3 will give you a straight line. So try to determine x and y intercept you should have y is equal to 3 and x is equal to 3, and then since we have this inequality less than, not equal to, so there is no equal to sign in this inequality, so I'm going to use the dash line instead. Okay, so it should give the idea to the audience that you will not consider any points that lies on the line. You just consider value x and y, or okay, which should be always less than 3. So when you have this type of domain, you have to sketch the domain, so it should be always like less than x plus y equal to 3, not including whatever points you have on the lines. So that's why we use the dash lines. So let's try to answer the next question, C. Okay, you have z is equal to z 5 minus x squared minus y squared. Okay, when you have this question, please again try to take a look on whatever you have on the right hand side. So basically this function of two variables is written in terms of radical function. So recall back, the argument of any radical function should always larger than or include to 0. So in this case, I'll note down 5 minus x squared minus y squared larger than or equal to 0. And then I try to recall the inequality properties. I'll get x squared plus y squared less than or equal to 5. So you should be able to write it and present it in the correct way, such as domain of function f is equal to set of all possible values x, y, such that x squared plus 5, oh my mistake, x squared plus y squared less than or equal to 5. So again, if the question asks you to sketch the domain, so let me improvise my question, sketch and shade the domain. So what should I do? I have to sketch it in two-dimensional coordinate system that involve y and x. So try to sketch x squared plus y squared equal to 5. So basically this equation will give us a circle, and this circle we will use solid line instead, because according to what we have over here, x squared plus y squared less than or equal to 5, there is equal to inequalities, so we will use solid line instead. And this circle, the radius will always be set 5, and it should center at the origin, and based on the inequality it is less than or equal to 5. So I want to sketch and shade the domain. So basically this is where I should shade the domain. Okay, I think you can read about how to determine the range of functions, because the range is defined as values of z from the domain. And I believe we have gone through the phase where we discuss how to sketch any surface in three-dimensional coordinate system. Please recall back about how to sketch a paraboloid, how to sketch a plane, a box, a sphere, an ellipsoid, a cone. So basically this section is everything that we have discussed from chapter 1.2 onwards. So I don't think that I have to recall back the way to sketch a surface in 3D. And I think maybe we can try to look at exercise 3.1. and try to answer a few questions. For example, let's take a look on question 2 for question B, such as determine domain of fxy equal to 4 over 5x plus e to the power of 1 minus x plus y. Okay, so let me change the color of my pen. So how to solve? Right, if you look at the functions listed on the right hand side of this function of two variables, it is actually the combination between two different functions. The first one, which is polynomial, and this is the mixture between exponential, and its indices is written in terms of radical function. So when you have this question, take a look on the first term. It shouldn't be any problem with the first term, because for x it should always range from negative infinity, or x belongs to any real number. Meanwhile, there is some occasion that you need to address for the second term, such as it is the combination between exponential and radical functions. When you have this type of terms that appear on the right hand side, so basically any exponential function should always from negative infinity until infinity, the domain. But when you have this question, you have to pay more attention to the indices of this exponential function, such as there is some restriction because the indices is written in terms of radical function. Therefore, the radical function 1 minus x plus y should always larger than or equal to 0. And what should I do? I try to write it in the form I familiar with. So I will have y minus x larger than or equal to 1. So the domain of this function can be written as set of all possible values xy such that y minus x larger than or equal to 1. So if the question asks you to sketch the domain, sketch and shade. Let me improvise the question. Sketch and shade the domain. So always remember, for function of two variables, the domain will always lies on xy plane in two-dimensional coordinate system. So I'll sketch the two-dimensional coordinate system that involve y and x axis. Again, y minus x equal to 1 always give you a straight line. Okay, try to determine the x and y intercept. So in this case, y intercept equal to 1 when you let x is equal to 0, and x is equal to negative 1 when the x intercept is x is equal to negative 1 when you let y equal to 0. So I'll get, okay, and the question, the domain is y minus x larger than or equal to 1. So I should sketch the upper part of this graph. Okay, so basically the shaded region will tell you that you can choose any points on this. I believe I did some mistake, so let me correct it first. So let me jot down or sketch the axis first, y versus x, and y intercept is y intercept is 1 and x intercept is negative 1. And I should have solid line instead of dashed line. The reason being, I have larger than or equal to inequalities. So I should always consider, okay, based on the inequality, I will shape this region instead. So it should mean something. You can choose any combination or any possible values x, y within the shaded region. If you choose possible values x and y in different region, you will end up with undefined values. I think that's it. So let's meet again in another video. Don't forget to like and subscribe.